Alright guys, welcome back to another brand new Unreal Engine 4 tutorial. In this tutorial we're going to work with the top-down template. What I'm going to show you really is just how to get your camera to actually move to either the left, right, up, down, or the diagonal directions just by having your mouse hit the edges of your screen. So kind of like an RTS style kind of camera where you move your mouse to the edge of the screen and it goes in the direction that your mouse is pretty much going in. So for the purposes of this tutorial, make sure you have the top-down template downloaded, and this is Unreal Engine 4.15.1, I believe. I did a couple of things for my initial setup that I probably won't go down and talk with you guys really about. Like I created my own game mode, I created my own game state, I created my own HUD class, my own player pawn class, and my own player camera manager class. Player controller class and player state class. I just created all of those by default for this project. So if you want to go ahead and create those yourselves, go ahead and do that, and then you can start from there. So one of the first things I believe though with the player controller, what you'll want to do is for show mouse cursor for mouse interface, just make sure you show the mouse cursor, and also enable quick events if you end up wanting to use quick events, which most likely you'll want to if you're using an RTS game. And then what I do in my player controller is when you first start playing, I set the mouse to the center of the screen, and this will work no matter which screen window size you have. It'll always just go to the center, which is nice. So let me show you how to do that real quick, and then we'll actually jump into the meat of things inside of our pawn. So basically, luckily in the player controller class, you have a function just called set mouse position, and you can get that just by typing that in, set mouse position. And since we're in the player controller, it's there. And then you pass through an X and Y coordinate set, and I'm using a function that I made called get screen center that returns an X and Y. Basically what I do is I get the viewport size, and I also get the viewport scale. So from the X of the viewport size, I divide that by the viewport scale, and then divide that by 2 to get the center. And then I just truncate it to actually convert it to an integer again. And I do the same exact thing with the Y. I get the Y, I divide it by the viewport scale if there is any, divide it by 2 to get to the center, and then truncate to get an actual integer back. And of course, I make it a pure function just so there's no need for executional pins, and I can just plug it in, and then on event begin play, we set it directly to the center. If you don't incorporate the viewport scale, I noticed that it actually won't do the center for whatever reason, so I guess by default it does have a weird viewport scale that it needs to divide by to actually get the true center. So don't forget to do that. And now we can actually get started with most things. It's pretty straightforward. Obviously, I'll walk you through it, but I have my player pawn. I'll start this all from scratch with you guys, so you don't really have to worry, but I'm going to do a brief overview. I have a pawn. In that pawn, I have a spring arm, and I have a camera. Nothing too crazy. But we have camera lag and rotational lag just so we get kind of smoother translation. And then basically what I do on tick, first I have a boolean that asks if I can move the camera. That boolean is just there for the purposes of in case you want to do other things. Like say for example, you want to select an object, and when that object's selected, moving the camera the way we're going to set it up won't work until you're done focusing on that object. And then if it is true, if we can move the camera, we have something called direction. Direction is a custom enumeration variable that I created. I'll show you how to do that as well. But we basically calculate the direction based on the mouse position and the viewport size, from our player controller. So we basically do a couple sets of mathematical procedures to see which side the mouse is on the screen, and then based on that calculation, we return a direction. So we have up right, down right, and right, and then we have up left, down left, left, and then up, down, and then none. And so based on that direction, we set our directional variable, and then we basically add world offset, and we apply directional movement based on the direction. So left direction, this is the this is the vector we want to return. For right direction, that's the vector we want to return. You know, we're basically coming up with different vectors based on the direction to then apply to the add actor world offset. So we're moving the entire actor with these movements. And we have a couple of variables like our screen border buffer, and we have a camera speed to see how fast we want to move. Then we have the direction and the Boolean. So let's go ahead and get started. I'm just going to move that off to the side as a reference for myself in case I forget anything. So again, we have our own HUD, we have our own player controller, we have a camera manager class. You know, nothing special about any of these. I just created them just to have them. The only thing we really want to make is our player. So we have our top-down player pawn, as I showed you. So let's just create a new one. Do blueprint class, do a pawn. I'm going to just call this BP example top-down pawn. And I'm using a pawn more or less because of the project I'm working on. I kind of want to be able to potentially possess other pawns, so it's usually easier doing it that way. And you typically want to use a character more for like multiplayer purposes. And if you have a single character, you don't want to have to change and possess your character. But now that we have our new pawn, let's also create our directional enumeration. So I have one here, like I said, but I'll show you how to make it. What you can do is right click under blueprints, you have enumeration. I'll just call it example player direction. And then from here, you have your enumerator. So you can just add as many as you want in whatever order you want. So, you know, obviously we might want to have none, and then we would want to have like up, down, left, right, up left, up right, and also down left and down right. And obviously you can use these arrows here to change the order of everything, but this order right now is perfectly fine for what we want to do. So let's close it out and just save it, make sure it's good. And now we can actually go into our pawn. And let's make sure in our scene we have our game mode. But let me go ahead and replace the pawn with our example. So now if we play, you know, we got nothing really, it's just a different camera perspective. So the first thing we want to do is create two things. We want to do a spring arm, and we want to do a camera. And for those who don't know what a spring arm is, it's really just, like in the simplest way, it's just a way to set a target length between the object center to wherever your camera is. So like the longer the spring arm, you know, the further away the camera is going to be. It actually works kind of like a spring arm would if you were actually like filming a movie with a camera. You know, you can interpolate between the target lengths, and you can do a lot of cool stuff with it. But we have our spring arm, and before we actually attach our camera, let's set up some parameters here. So my target arm length is 1200. As you can see, it gets longer. And when we actually attach a camera, so let's do that right now actually. When we attach a camera, it automatically goes to the end of the spring length, which is really cool. Okay, now see, as you change the target arm length, the camera, or whatever object is a child of your spring arm will move accordingly. So again, let's just do 1200. And we'll also want to give the spring arm itself a rotation so that it's, you know, bringing the camera upwards. So I saw that -60 was pretty good. And you'll notice that the camera, because it's a child of the spring arm, it also adjusts its rotation to -60 as well. Now, a couple other parameters for do collision tests. We're going to turn that off. With collision tests, what it does is, you know, what it sounds like it does. It does a collision test between the spring arm length and the origin, and if anything hits it, it tries to adjust the position accordingly. But sometimes it doesn't really work out, especially with the target arm length of this length, like 1200. Maybe for shorter lengths, it would work better for like a third person. But for an RTS, we kind of want to stick with that. Camera settings, we can leave those alone. And then what we'll want to do is enable camera lag. And later on, if we ever want to add a rotation, we'll do rotational lag, just so it's a smoother interpolation between the two positions and rotations. So I found a good number here would be 7 for the lag speed, and we'll leave 10 alone for the rotational lag speed. Now that we have that, we actually don't really need to change anything with the camera. The camera is perfectly fine as it is. So now if we play, we have a good perspective. But you'll notice, I'm moving my mouse to the edges of the screen and nothing's happening. So we'll need to add that logic next, which is the meat and potatoes of this whole thing. So typically I like to create my variables first as I recognize them. So the first one we'll want to do is a float. We're going to call screen border buffer. And typically, obviously it's going to be a float, so let's change that real quick. You could, if you really wanted to, have different buffers for the different sides of the screen, but I like to keep the things consistent, so we'll just have one buffer for all sides. And I saw that about 50 is a good size for us, so we're going to set that. We'll also create something called camera speed. It's going to be a float as well, so we can just duplicate that, name it camera speed, compile and set its value to 10. And now we're going to create the enumeration variable that we just made. So I believe we called it, has the word example in it, right? Yeah, example player direction. So either it's going to be called player direction or example player direction or whatever you named it, but it's going to be under the enums category. And we're going to call that direction. And just so we have it, let's go ahead and make a boolean for B can move camera. Make it a boolean. And for the most part, we're going to be using the event tick because we have to make interpolations and changes. Typically, I don't like using timelines that much, but that could be an alternative way you can do this. But event tick is pretty simple, so we're going to use that instead. So the first thing we're going to do is put in our boolean for can move camera, branch it, and set it, see if it's true. By default, let's set this to true. Compile that. And now we need to set our direction variable. So first let's put it to true. See, right now it's going to be set to none, so what we need to do is create a function that returns the proper direction based on our mouse location. So let's create a new function and we'll call it getDirection. And what we'll do first is we'll do up and down, because up and down is pretty straightforward. So let's also just make sure with this one we're going to make sure it's a pure function, and we want to make sure it has an output for our direction variable. So example player direction, and we'll call the output direction. So let's start by going up here. So if you kind of think about it, I believe with Unreal it draws its screen. So 0, 0 is the top left, and then the bottom right is how you would kind of grow and expand. So 1080 down, 920 across left and right. So if up is going to be 0, that's what we want to kind of compare ourselves with. So let us go and check that out right now. We need to get our player controller because that has a function there that we can pull from it called getMousePosition. And we can actually just kind of print that out just so you can see it. So we'll just print our X. And in order to get this to print, we need to kind of hook it up real quick. So as you can see, 381. 0, about 1920, 1919, I guess. So you can see how that works. So that's the X. And obviously we could just print the Y out real quick so you can see what that is. You'll see a similar thing, except it's going to go down to 1080. Let me expand this out. So you can see that's pretty much how it works. So it's pretty simple at this point to kind of get things going. So what we want to do is check to see, hey, is our mouse position in the Y, because we're doing up and down first. We want to check if it's greater than 0 or greater than or equal than 0. And we want to see if it's less than our screen border buffer, which was 50. Or we can do less than or equal to. You can do that one as well. So let's grab our screen border buffer. Now we need to use an AND boolean. We basically want to check, hey, is this true? If it is, we'll set the direction to up. If it's not, we'll set direction to none. And now we can literally just print out our direction. And we should see it, we won't see any translation yet because we haven't done that much yet, but we should see the prints now. Where it says none, up, none, up. And then you can basically adjust this based on your screen border buffer. So 50 again is pretty good for what I think. So again, for up, we're getting the mouse position, we're checking the Y, and we're checking if it's greater than or equal to 0 or less than or equal to screen border buffer. So we're checking if it's within that magic value between 0 and 50. So now, with that in mind, the way we would do up, or I'm sorry, the way we're going to be doing down is we have to take into consideration the viewport size, because we want to check if the mouse is then less than, or no, that it's greater than or equal to the viewport size in the Y minus the screen border buffer. So hopefully that'll make sense in a second here. So let's get our viewport. From the player controller, you can get viewport size. We'll want to go ahead and convert this size Y to a float. And now what we can do for Y, we want to check if it's greater than, or we can do greater than or equal to the value of our viewport size minus our screen border buffer. So if we're doing 1080 as our viewport Y, we want to check if it's greater than or equal to 1080 minus 50, which is 1030. So we want to check if that's the case. But then we also want to check if our mouse position is also less than or equal to just the full size of our viewport in the Y. And then we can drag an end here. We need another branch. We can plug these guys in. So this gets kind of messy. It's not too bad, but it could be much cleaner. But hopefully this is making sense here. So here, this is where we're at the bottom, right? So direction is down. And then if this is false, let's just set that to none. So we have none, we have up, and then we have down. So that's working. So right now we can do one of two things. We can first complete the rest of these omnidirections here, like left and right, and up left, up down. Up left, up right, down left, down right. Or we can first now try getting things to actually move. So I think we'll actually want to get things to start moving, just so we can kind of break it down in that way. So what we want to use is something called Add Actor World Offset. We don't want to perform any sweeps or teleports, so we'll set those to false. What we really need to provide is a delta location. And to do that, we need to basically find out which direction we want to move and multiply that by our camera speed. So if we're going up, we want to move the camera up in that direction. But up is really not what you think as up. It's really just moving north or forward, really. So let's go ahead, and we'll need to create a new function. And this function is going to be called apply directional movement. As usual, we'll make this a pure function so we don't have to deal with executional pins. And we'll want to do an output of a vector, a normal vector there. We'll call this directional movement. And what we'll want to do is, using our variable direction, and again we're setting that here, we'll get direction, and we can use a cool little node called select, and it takes in consideration every single part of our enumeration with select, and we could just return the wildcard value into our directional movement, and that changes everything to an XYZ coordinate that we can then apply as our directional movement. So with up being our first one, let's go ahead and get the up direction, and we'll use a macro just to make things really clean. Call it get up direction. We'll just want to have an output value. It's going to be a vector. We'll call it up, and what we'll need to do is get our actor forward vector, because again moving up is moving forward in this case. And all we really have to do is multiply this vector by a float, and that float is camera speed. So we're basically getting our forward direction and multiplying it by 10, 20, whatever number you want, and then applying that vector to our directional movement in our add actor world offset. So what we can do is in our apply directional movement, let's grab our macro. It should look something like this. And we'll just plug it into up. And then we need to go back to our main event graph. And now we need to call apply directional movement and plug it into our delta location. So now, technically, we should be able to just move the camera up. And there you go. Looks pretty good. You can, of course, change the camera speed to make it faster, slower, whatever you want to do. And for the spring arm, if you increase, how does it say here? Okay, so if you increase it, the camera lag, the less lag you feel when moving. So like if I change this to like 50, for example, you're not going to see any lag. It perfectly stops. But if you set this like 1, and then move, you'll see it lags behind. It takes a while to slow down. So I found 7 as a good value for that, but go ahead and feel free to play with that as well. But now that we got up moving, we might as well get down moving as well. So we can always duplicate our macro here. We'll call it get down direction. And we'll just change the output name to down. And all we really need to do with the down direction is take our vector that we have, because again, this is moving forward. If we want to go backwards, just call negate vector. Just makes it negative, and it goes the other way. And you're going to have to keep that in mind too when we do left and right in the diagonal. It's pretty much getting the vector you want for the positive direction, and then using the negate vector to bring it the other way. So let's change that. Now we should be able to move down. And we can. So up and down. It's pretty good. So now let's do left and right. So left and right, almost the same idea. What you would need to do is, like for example, if you want to go left, you can almost copy the exact stuff we used for up. The only reason why is because left is the 0 of the horizontal direction. So, speaking, not technically, but like speaking relatively simply, you just gotta replace x, or you should replace the y with an x. We should get the same thing. So let's do a branch. And then if this is true, we'll call this left. We just gotta make sure we print. Okay. So now we should get left, and we do. Obviously we don't get none again because we need to put this back. There we go. Left, none, left, none. So now we got left and right. I'm sorry, now we got left, but now we can do right. So right is going to work a lot like down, because we have to then check the opposite situation. So let's just copy the down logic. And what we have to do, let's disconnect all the y's here, put in an x, disconnect the size y here, and use an x. And that's really it. So now we can call this direction right. And then if it's false, we'll call it none. So now if we play, we got left, and then we got right. Perfect. So now that we got left and right, let's go ahead and add those directions too. So, like I said earlier, get up direction is kind of similar to our get left. So let's duplicate that one. Do get left direction. Now instead of get actor forward vector, what we can do is get our right vector. So get actor right vector. And because this is left, I kind of misspoke how they were kind of similar, but because we're using a right vector, if we want to move left, we then have to negate this. So we should have really copied the down one and just replaced the get up vector with the get right vector. But you'll live and you'll learn. And let's just name this left. And while we're at it, let's just make our right direction. Let's just duplicate our get left, get right direction. Rename its output to right. And we just got to get rid of this negate vector and plug this in. So now we should have left and right. There's left. Alright, it doesn't look like right's working, and I know why, because we didn't even put it in. There we go. So let's try that again. There's right, there's left, and that's perfectly good. So now the last part, we can do one of two things. One, you guys can try to figure this out on your own and try to finish the video without this extra step, or you can just follow along and see how I do it. It's really depending on how you really want it. If you really want to challenge yourself, because what we're going to try to do is we're going to try and get the diagonals working. Because now, really, if you go like diagonal, like it doesn't really work. Depending on where your mouse is, you're either going to go up or left or down and left. You're not going to be able to go in that diagonal direction. So, what we can do is, let's use our left. So what we'll want to do, if we are, let me see here, I gotta double check. Yeah, okay, so if we want to do this, we'll want to do it up here with up and down, because they're the first ones that we check for. So basically, if we're moving up, we then want to check if we're moving left. So let's copy this. If we are, we then change this direction to up, left. If it's not, then let's go ahead and check if we're moving right. So we can just copy that from the bottom. If we are moving right, then we can call up right. And then if we're not going up left and we're not going up right, then we're just going up. So we can change that to false. Whoops. Make this false and set it to up. And now we can kind of check it out and see if this works based off our prints. So up, 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 left. Left, up, left. Right, up, right. Up, up, right. So we got that working. And then it's going to be the same idea for down. So what we can really do is make some room for ourselves here. And just copy this logic. The only thing we're going to change is the direction that we're returning. So now we would use down left, down right, or just down. The reason why we're doing it this way is because the first directions we check are up and down. If our directions we were going to check were going to be left and right, we would actually then go from, check if it's left, and then check if we're up, or check if we're down, and change that accordingly. So let's just double check this. So we're at none, we're at down, down left, left, down left, down, down right, right, down right. So perfect, that's all we need. So now all we really have to do, let's get rid of this print string. We don't really need that anymore. All we have left to do is add vectors together, really. It's pretty straightforward. So for up left, we gotta get our up direction, we gotta get our left direction. We just gotta add the two vectors. Now we have up left. Let's just check if that works. Up, up left. And now we got that cool diagonal movement. So now we can just do the same for the rest. So upright is we're going to multiply the up direction. We're going to add the up direction to the right direction and return that result. And then we can do the same thing, except this time with the down direction. So just copy that whole thing, get down direction and replace that. And then plug that in accordingly. So down left and down right. Now, we got up left, we got up right, we got down left, down right. Whoops, that's wireframe. So that's pretty much it. For none, you really want to leave it at 0, 0. You don't want to do any additional offset. But from here, you could do a lot of cool things. Maybe in the next week's video, I'll try to see if we can get some cool rotation going, depending on the control set we want. But I really wanted to show up this mouse position kind of movement for an RTS-style kind of game, because I made another video showcasing it, but I never made a tutorial for it. So I thought I would make it. So as a quick recap, we got our spring arm. We got a spring arm with about 1200 length. We attach our camera as a child to that, and it automatically gets set to that length, that 1200 distance. We also made it -60 rotation for the spring arm, and because the camera is a child, it will follow that rotation accordingly. We turned off do collision test because I'll show you, if you have collision test, you're going to get stuck. You're going to hit a wall, and it's not going to show everything correctly. So let's turn that off again. Then enable camera lag and enable camera rotation lag. You don't really see camera rotation lag because we're not rotating the camera, but we do see the camera translation lag, and we set that to 7. And again, the higher the number, the less lag there is. The lower, the more lag there is. 7 is a good number that I found. And then we also, for this project, we created our enumerator, our enumeration, our example player direction. It has none, up, down, left, right, up, right, down, left, down, right. And we made that a variable called direction. We also made a variable called B can move camera. And then we also have screen border buffer. The higher the number, the less extreme you have to move the mouse towards a direction for it to start to move. So if you want more loose controls, you can make that number higher. By default, we set that to 50. And then camera speed, again, is how fast we're moving. So if we set this to like 30, step 10, we should move 3 times as fast, and we do. So that's something cool we can do as well in the future, where we have some UI at the top that you can control the camera speed on a slider. That's always something cool you guys can try to do. Let's set that back to 10. And then, we get our direction, and we set our direction variable. We get our direction based off our mouse position compared to where we want to go. So if we want to move up, we're comparing our mouse position so it's between 0 and 50. For down, we're going to try to compare the length of our Y minus 50, see if we're in that range. And then for left and right, it's the same idea, but with the X direction. And then if we are moving up, we then check if we're moving left or if we're moving right. And if so, we do up, left, up, right. And if we're going down, we then check if we're going left or right, and then do down left or down right accordingly. But once that's all done, we apply our directional movement. We get our up direction, which is just our forward direction times our camera speed. Our down direction is our forward vector times our camera speed, but with a negated vector. Left is a lot like down, but it's a right vector times our camera speed and negated with their vector. Right is just our right vector times our camera speed. And then our omnidirectional, our fucking diagonals, are mathematically added. So up plus left, these vectors will get us up left. Up plus right will get us up right. Down plus left will get us down left. And down plus right will get us down right. So that's pretty much it for this tutorial. Please let me know if you found this interesting, if you want to know more, because I am interested in kind of doing some more things with this kind of camera. I don't know how far I want to go, but maybe enough for some interesting tutorials. Make sure to leave a like. If you haven't already, make sure to subscribe. And also let me know if there's any kind of topics you want me to cover, because right now, again, all I do is cover things that I find interesting. So just let me know in the comments if there's something that interests you, and I'll work on it as well. And until the next video, I'll see you in the next time.
Just hold on, we're going home. Just hold on, we're going home.